Welcome to the first tutorial video for Mathematics 114. So what is the idea of these videos? The idea of these videos is to do problems similar to the ones that you will have to do in the tutorial. It will hopefully help you with your thinking process so that when you have to attempt these problems on your own, you will find it a little bit easier. So the first exercise we will be looking at is the exercise on page 2 of your notes, and we are looking at number 2a. The question asks us to say how many elements there are in this set. So when counting the elements in a set, what's the first thing that we have to remember? The first thing we have to remember is that we count each element only once. In other words, if a certain element occurs more than once, like 2 in this case, we count it only once. So let's count the number of elements in the set. So we have 1, then we have 2, then we have another 2, but we won't count that 2 because we've already counted a 2. Then we have 3. And then 2 more 3s, which we don't count because we've already counted a 3. So our answer here is 3. There are 3 elements in this set. The next exercise we're looking at is under section 1.4, and it is on page 4. We are looking at number 1a. So we are given a set, and we are asked to write down the elements of this set as a list. So let's first read this set. So this set consists of all x, given that 3x is an element of integers and x is between 0 and 2, where 0 is not included but 2 is included. So let's first present the possible values of x on a number line. So we know that x is between 0 and 2, where 0 is not included, but 2 is included. Let's see between which values 3x will therefore lie. We know 3x is an integer, and it can't be 0 since x can't be 0. So what's the first integer greater than 0? 1. Let's look at the largest value 3x will take on. The largest value 3x will take on is the value we get when x is 2, because that's the largest value that x can take on. So the largest value that 3x can take on will be 3 times 2, which is 6. And then we know that there are still other integers in between 1 and 6 that 3x can also take on. So we have a 2, 3, 4, and 5 in between there. So what we want to do now is we just want to find the values of x such that 3x takes on the values 1, 2, 3, 4, 5, and 6. So we already know that 3x equals 6 when x equals 2. Next, 3x will equal 1 when x equals a third. 3x will equal 2 when x equals 2 over 3. 3x will equal 3 when x equals 1. 3x will equal 4 when x equals 4 over 3. And finally 3x will equal 5 when x equals 5 over 3. So I'm just going to fill in those values over here at the number line. So we have a third, 2 over 3, 1, 4 over 3, 5 over 3. And we know x does not take on 0. So our answer here is going to be the set consisting of the elements 1 over 3, 2 over 3, 1, 4 over 3, 5 over 3, and 2. The exercise we're looking at now is the exercise on page 7 under section 1.6, and it gives us 3 sets, A, B, and C. We are going to be doing numbers D and E. So let's first look at D. What do we have to determine at D? We have to determine A's union with the intersection of B and C. Okay, so what is the intersection of B and C? What does that mean in words? Think about that for a second. That means it's all of the elements in both sets B and C. So let's find those elements. The first element in B is 2. Do we have a 2 in C? Yes, we do. The second element in B is 4. That's not in C. 6, that's not in C. 8, that's not in C. And 10, that's not in C. So the only element occurring in both B and C is 2. Therefore, the intersection of sets B and C consists of only the element 2. We now want to find A's union with the intersection of B and C, which is only the element 2. So A's union with the element 2 will just be all of the elements in A, and we add the element 2 to it. So the answer here is going to be minus 1, 0, 1. Then we added 2 and 3. Let's now look at E. In E, we want to determine the set C without the elements that also occur in set A. So let's look at the elements in set C. We have a minus 3 in set C. Do we have a minus 3 in A? No. We have a minus 1 in C, which also occurs in A. We have a 1 in C, which also occurs in A. We have a 2 in C, but that's not in A. And then we have a 3, which also occurs in A. We are only left with 2 elements in C that do not occur in A. Therefore, the answer here is going to be a set consisting of only the elements minus 3 and 2. The final exercise we're looking at is under section 2.4, and it is on page 15 of your notes. We will be doing number 6A. The question asks us to use a truth table to show that the following statement is always true. The first thing I'm going to do is I'm just going to read what the statement says. Try and do that by yourself. Pause the video for a second before you listen to it. So what does the statement say? It says P implies Q if and only if not Q implies not P. So what we want to do here is we want to show that this statement is always true. In other words, we want to show that whenever P implies Q is true, then not Q implies not P is also true. On the other hand, whenever P implies Q is false, then not Q implies not P is also false. If we've shown that, we've shown that this entire statement is indeed true. Just note that on the bottom right of this page over here is the definition of the conditional statement P implies Q as it is on page 13 of your notes. Okay, so let's fill in this truth table. Firstly, I'm just going to fill in the first two columns. They're going to be exactly the same as the first two columns on the bottom right. We are just going to fill in all of the possible true-false combinations of events P and Q. So I'm going to fill in true, true, false, false, and then true, false, true, false. Now I'm going to fill in the column P implies Q, so this column. This column will once again be exactly the same as the column we have here at the bottom right. But let's just look at it row by row. So firstly, we have in the first row, we have true implies true, which is true. In the second row, true implies false, which is false. Third row, false implies true, which is true, and false implies false, which is true. Next, I'm going to fill in the column not P. The column not P will just be the exact opposite of the column P. So when we have P is true, then not P will be false. So we have false, false, true, true. Not Q will just be the exact opposite of the column of Q. So we have false, true, false, true. Please just note the mistake here in this next column. It's not supposed to be not P implies not Q. Just going to change that. It has to be not Q implies not P. Okay, so let's fill in this column now. So we have, firstly, in the first row, we have false implies false. That is true. In the second row, we have true implies false, which is false. It corresponds to that row, the second row, in the definition of a conditional statement. In the next row, we have false implies true, which is true. And finally, true implies true, which is true. So what were we trying to do again? We were trying to show that whenever this statement is true, then this statement will also be true. And whenever this statement is false, this statement will also be false. So can you see that that is indeed the case? Whenever this one is true, the second one is also true. And in the one case where it's false, the second one is also false. Therefore, we have shown that these two statements are equivalent. In other words, P implies Q if and only if not Q implies not P. So these are all of the exercises we will be covering in this week's tutorial.